enough time? Plenty of time then. Sorry, bit late. Picked up an egg chicken for 99p.
Onwards.
Okay, so the addition mechanism. We mentioned in part 2 that we're going to do this.
And now we're actually going to do the mechanism.
Finally got around to it. So let's do it.
I'll write up a equation.
Alright,
So the usual
simple thing. We have this ethene, and we're going to add bromine to it. Now, the difference between addition reactions and substitution reactions is the homohydrolytic fission thing, but really, in substitution reactions, the homolytic reaction is started by UV light.
Yes, UV light will cause it to happen, it will cause it to break, it will cause the covalent bonds to do what they do, where an electron goes to each one to make the radicals. In this case, it doesn't work like that.
No, it's caused by the double bond, actually.
Yes.
And we're going to how that happens.
These two things combine to make one thing in addition, whereas in substitution,
something swaps.
Two things make two things when the things are swapped.
Yeah. Alright, so let's do that now.
Okay.
Alright, let's do it.
I'm not going to write this until the end, so you can understand how we get to it, hopefully.
Yeah.
I'll change to green.
Good plan. This one's not a chain reaction, so there's not loads of steps. So we have our ethene, and we have these bromines that are just chilling, just going below the double bond. But because this is really negative, like mad, what that causes, it pushes the electrons down, and that makes a dipole.
So this will be slightly positive because all the electrons, well not all, but some of the electrons will be pushed away. So it's slightly more positive and slightly more negative here because it's gained some more.
And then
this then forms, because this covalent bond has two electrons, it then forms heterolytic fission.
Which means two electrons go down to the bottom one, forming ions. The top one becomes a positive ion, bottom one becomes a negative ion.
This is so positive and this becomes, because this is so negative and this is positive, it then attracts it, breaks this bond, that then goes and bonds to that.
This brings us to an intermediate stage, where we have an ethene with one bromine on it.
Like this.
Like there. But the other side, there's something missing, and we denote that with a little plus, which means this is electron deficient.
Yes, and this negative ion is still around.
Just a sort of, it's bubbling about there.
Draw it like this with all of its
it's got
electrons.
a full octet. And that's attracted to there. So,
this is a nucleophile.
It is a nucleophile.
And it attacks electron deficient carbon atoms, so it does literally do that.
It does literally just attack there. And that's what gives us our final product.
Which is carbon to carbon.
And there's two bromines there. And
H.
then we go on to naming this.
Yep, which is normally it's a mark thrown on at the end of a big question, just for an extra mark.
And it's called 1,2 bromo ethane.
Bromo ethane.
And that's the addition bit. That's that.
Should mention that the curly arrows represent the movement of electrons.
Yeah.
So, and when you get to A2, you do different types of arrows.
Yeah, you do.
One-sided
like a
arrows.
fish hook for one electron moving, and a double-headed
At the minute,
for two.
it's satisfactory to just do the arrows exactly like this, as long as you show them in the right direction. That goes to there, that goes to there, and that goes to there.
Yeah.
This is the mechanism for addition.
It is. Now we're on to industrial stuff.
Yes.
All right.
Let's crack on.
Let's crack on.
I think the cat wants feeding.
I think we're back.
With polymer chemistry.
Yay.
Poly essentially means a lot of something.
Yeah, like repeats of something.
And polymers are always repeats of
A monomer.
alkenes.
Oh, okay.
And they are, the alkenes are monomers, that's a special word. So if we have polyethene, remember
lots
the
of
part in the
repeats.
brackets is what changes, you can have poly something else. This is the simplest one. Ethene looks like this, I think we're familiar with it, but these four parts.
We've done it a little bit.
Poly means lots of, so you put it in square brackets.
You do.
And do it to the n, where n is the number of monomers.
It could be lots of them, it could be like 2.
Because they join together, you can't have this double bond because of the amount of electrons carbon has available.
So,
you quite simply get rid of it.
we do. And we put that bit there.
That are there, they've got to go upwards because of the amount of electrons and the repulsion between things, they then go in this form.
And then these lines just go outside the square brackets to wherever the thing is.
Yep, and then this would bond to more and more of the exact same thing. So this line will be joining to another one, which would then join to another one n times.
Yeah. So if we were to write that entirely algebraically,
you would have
C to C, and you could have A, B,
C, D.
To be really imaginative. And have it in all that in square brackets.
N remains the same, it's just N.
It is.
You'd have single
So
bonds.
that'd be A, B, C, D. So you flip them for some reason because I read it out this time.
Oh, well, I'll put them right way around just to
Just
avoid
to
confusion.
Avoid confusion. But you should be able to find that, it's not very complicated.
And that is that.
And that's what polymers are.
Everyone's familiar with polystyrene for some reason. So I'm going to go ahead and I'm going to actually draw polystyrene in this form we've just
I
done.
think that's a good plan.
Yeah.
Polystyrene is a polymer of something else.
Yes. And this is what the monomer looks like. You've got the carbon, double bonded to carbon being the focus.
Yep.
And everything that comes off that. This goes to this shape.
Yeah, it goes to a cyclic.
Now you could write this out as carbons, but because this is the focus, you just need to do it in this form.
Yes.
And then in the square brackets, you don't need to draw anything extra special. You just do it like we did algebraically in the time before.
So we have the C. This would be the D, I guess, in the case we had it before.
Yep. You just draw it like
But we
that.
just draw it like that. Those would be H's because for hydrogens we haven't got anything else. And then lines go off the side, as usual.
And it's just drawn
And that's
like
the
that.
monomer.
Yes. You don't need to know about the circle inside a shape until A2.
No.
That means special things, but you just need to know if you want to draw this as its monomer, you do that, but you just take away the double bond and draw them upwards.
Yeah.
Quite simple. Doesn't come up often in exams,
Not a lot.
this whole thing, but it could come up and you would be expected to do this.
Yep.
Likewise, if you're given a chain of this without it being in brackets, you're given if n be 4 or something in an exam paper because they might have taken
and they
too
might
much
ask
room.
you to write it out.
They might ask you to select the monomer and put it back in this form as well. So you'd have to identify what's being repeated, circle it so that you've got a carbon to carbon, and then draw it like this. So you put back in a double bond, take off these bonds and draw it like that.
Yep.
So in reverse essentially.
That's quite simple.
Yep. We use polymers all the time because they're plastics. We use them. This is polymer stuff, plastics.
Plastic
Plastic
bags.
bags, cartons for drinks,
Yeah, there's
lids for stuff.
more or less everything you'll find a bit of plastic in.
Yes, including the factories that make plastic, ironically, will have lots of plastic things.
Yeah.
As you probably know from GCSEs, this isn't an advancement of anything you know.
No.
They're hard to get rid of. They don't biodegrade.
Yeah, if you leave them on the ground and come back a million years later,
They're probably still there.
they'll be there.
A few holes in, they'll be gone a little bit, that'll be it.
Yeah.
A little bit of deformation, that's all there is.
So,
If you burn them, they give off toxic fumes.
and that's bad.
That is
So you
really
can't just
bad.
burn them in like a big tip.
Yeah, like big furnaces is often how we get rid of stuff. You'd have to extract the plastic stuff, otherwise it would give off toxic fumes.
It would, and that's problematic. But you have to have something to do with them, otherwise the entire world would be covered in empty pens.
Yes, so we managed to adapt ourselves to recycling plastics.
Yes.
So when you actually put stuff in the brown bin, or the blue bin or the black bin, it gets separated out at landfill sites so that we can get the plastics, reuse the plastics or recycle them,
Yeah.
and then they're used again. So that minimises the put out there to just try and biodegrade, which they don't.
Yes.
Also, for rubber tyres, it's an expensive procedure, but we found a way to burn them
Yes,
and produce
and-
electricity.
And we
In a
control
controlled, otherwise it would give
We
off
take
toxic
out, we
fumes.
take out the toxic fumes and do something.
You
with
don't
them.
need to know what they do, and it won't
No,
come up in
it
the
won't come
exams.
up. But
The
yeah.
idea is there.
I do that a lot.
So I think now we go on and sum up part 1, 2, 3 and 4. This has been a massive module.
Yeah, we'll try to make the summary not so massive.
Yep.
Yeah, let's
do
do
it.
that. Wayne. Boop. Ah! Time for the mammoth summary.
Yep. We're going to sum up part 1, 2, 3 and 4 now.
Right now.
This is what to remember, so we need a bit of help.
Baby found a friend.
Phoned our friend Ocker,
Yep.
OCR book.
This is a book it didn't pick up, so,
So
we
we
just...
picked it up.
Yep.
Introduction to Organic Chemistry, the idea of alkanes and alkenes.
Yep, we went on to some functional groups.
And then homologous series
Which
of
goes,
alkanes
yeah,
first.
which goes something like this.
Methane,
Ethane,
propane,
butane,
pentane,
hexane,
heptane,
octane,
nonane.
and decane.
Nearly messed up at the heptane there.
Nearly, but not quite.
Then what
And
was
we
the
use
naming?
that for naming, because that's the prefixes.
Yep.
We went through that, there was a table up here.
And we did the general formula and stuff, and then we did displayed formula, what that means, and the structural.
Structural formula, there on skeletal formula.
This was now part 2 skeletal, so we started off with that, skeletal, then skeletal with functional groups.
Yes, it got more complicated. Basically, we just did what we did before, but using skeletal formula as it's a new idea.
Then it was isomers.
It was.
2 different types, structural and stereo.
Yep, stereo, the only one being EZ or cis trans, and the other one is quite a few.
Yes. And optical isn't introduced till A2. Then we did homolytic and heterolytic fission, and about nucleophiles and electrophiles, and addition reactions and substitution, but not the mechanism.
No, we just sort of explained vaguely what they were, and also there's an elimination reaction, which we just sort of stated.
Yes, there's not a mechanism that we know of.
Then we went to fractional distillation,
yes,
and all the fun you can have with alkanes.
And the effects of chaining, the length of the chain,
and
branching, which led us quite nicely into cracking and combustion and stuff.
Splitting much longer chains at the bottom into more useful chains higher up.
Yep.
And an alkene. On to fossil fuels.
For the future, the idea of what's bad with doing what we were just doing, and what's better with biofuels compared to that.
Yeah. Do comparisons, stuff from GCSE really.
This was a new video. This is part 3. We're on
part 3, and this is when we start up on the mechanism.
Yep, and this is the mechanism of substitution first.
Yep.
The radical one.
Initiation with the special light.
Yep, UV light.
UV light, and
then propagation, and then
termination, which ends it.
Yep. We did alkenes and
more detail of alkenes. We talked about the pi and the sigma bonds, and pi breaks first because it's weaker.
And there's more reactions. The idea that you have to know about hydrogen with the nickel catalyst, then the water one with the phosphoric acid.
Yeah. As a catalyst.
The different isomers you can make if your chain is a bit longer.
Yes. And
then that did a mechanism that we didn't do. We went on to the next page.
Yeah,
and this is now part 4.
It is. Where the next page is what the other mechanism would have been, which is an addition reaction.
Yeah, but we did it with Br2 instead of HBr.
We did.
It was a nice revision of it there, which is quite a nice thing.
Yeah, we weren't going to write it out because we'd have just copied it. But on page 133, it's quite a good summary of all the different pathways.
Yep. Then 17...
A lot about margarine.
17, 18, 19... and 20 is all about polymers, so we summed all of those pages up in one big go, which is the clip we just seen before the summary.
They didn't ask many questions on that apart from the polymer bit.
And we didn't do an examination question this time because it's the 4 different parts. It would have been really hard to do. Find an examination question that links it all.
But if you do have any questions, as always,
put it in the comments below and we will answer it.
Message us on Facebook.
Message us on Facebook.
We are Clever Cracker. Then does the word squared. They wouldn't let us do the.
Yes, so just type in clever cracker squared, no fancy up to the 2 or anything.
Yep, and we'll put a video of whatever you ask us.
Yes, because we couldn't do them all, that'd be bizarre.
Yep,
so.
And we'll do any exam board. There's a few differences, but we can cope with that.
We can cope with that. We can do OCR, XL or AQA chemistry already.
Yep.
That's it.
I think that's it.
That's it for these 4 parts.
So we'll see you in the next video.
Yep, Module 2, Unit 2.
Let's crack on.
Way looking James Trivett.
Absolutely.